Greetings, knowledge seekers. Miss Daniel here. Get ready for an exciting expedition into the world of density. By the end of this expedition, you will not only be able to define density, but you'll discover how to apply the density formula and describe examples of how density is important in our everyday lives. Our density expedition takes us to a place where the sun meets the sand and the waves whisper tales of the deep blue sea. There, we find Kelsey, the unsuspecting beachgoer about to embark on a density adventure. Join us as the expedition unfolds.
There I was, guys, just chilling on the beach with a refreshing coconut water, soaking in the salty breeze, watching the boats as they sailed by, and tossing some pebbles into the water. Then it hit me. No, not the pebble, but a question. A question arose in my mind. Why were the small pebbles sinking in the water and the large boats floating? Shouldn't these large boats or even ships sink? Something's fishy here, and it isn't just the ocean.
Confused and intrigued, Kelsey couldn't shake off that sinking suspicion, no pun intended, that there must be some scientific explanation for her observation. She would soon find out that the answer to this oceanic conundrum was hidden in the depths of the scientific wonder, density. What is density, you may ask? Density, represented by the symbol ρ, is defined as the mass per unit volume, where mass with symbol common M is a measure of how much matter is in an object, and volume with the symbol capital V is a measure of how much space the object takes up. Density therefore gives us an idea of how tightly or loosely packed matter is within a space. If an object is very dense, it means a lot of particles are packed tightly together in a small space. If an object is not very dense, it means the particles are spread out more and there's more empty space between them. Now you may ask, what do the sinking pebbles and the floating boats that Kelsey saw have to do with density? Well, less dense objects float and denser objects sink.
Hold up. So based on what you said, I can infer that the pebbles are more dense than water, so they sink, and the boat is less dense than water, so it floats?
Bingo!
How would one calculate the density of any object or material?
We can use the formula density is equal to the mass of the material or object divided by the volume of the same material or object. It is useful to note that the standard international unit for density is kilograms per meter cubed. This unit helps us to express how many kilograms are within 1 meter cubed of space. Let's look at this example. A pebble of mass 0.02 kilograms has a volume of 0.00001 meter cubed. Find the density of the pebble.
Okay, I'd like to figure this out. I'll first pick out the information given in the problem. We were given that the mass of the pebble is 0.02 kilograms. We were also given that its volume is 0.00001 meter cubed. The question asked us to calculate the density of the pebble. Okay, well, since we know the formula to calculate density, I'll write that down first. There it is. Density is equal to the mass of the material or object divided by the volume of that same material or object. Next, I'll substitute the information that was given in the problem. So instead of writing M for mass, I'll replace our M for mass with its numerical value 0.02 kilograms. Next, I'll replace our V for volume with its numerical value 0.00001 meter cubed. This will give us an answer of 2,000 kilograms per meter cubed.
Correct, Kelsey. Very good you. Let's compare this value to the theoretical value of the density of water. Do you know what this value is?
I'm not sure.
Well, the density of water is 1,000 kilograms per meter cubed.
Interesting. If we were to compare the density of the pebble and the density of water, we would see that the density of the pebble, 2,000 kilograms per meter cubed, is much greater than the density of water, 1,000 kilograms per meter cubed. That pebble would definitely sink in water since its density is greater than that of water.
Okay, Kelsey, I think you're a pro at this. Let's look at this question, which asks you to find the density of a ship.
Sure.
A shipbuilder wanted to ensure that his ship would not sink when out at sea. He wants you to calculate its density. Additionally, he indicated that the mass of the ship is 20,000 kilograms and its volume is 40 meters cubed.
Okay, this is easy. The problem gives us the mass of the ship, 20,000 kilograms, and its volume, 40 meters cubed. The shipbuilder wants us to find the density of the ship. I'll first state the formula for density. Then I'll substitute. Our answer is 500 kilograms per meter cubed.
Yes, that is correct.
If we compare the ship's density, 500 kilograms per meter cubed, to the density of the water, 1,000 kilograms per meter cubed, we can definitely see that the density of the ship is much less than the density of water. The shipbuilder has no need to worry then. His ship would definitely remain afloat.
Yes, Kelsey, and this scenario highlights one example where density is so important in our everyday lives. Ship designers and builders must take into consideration the mass of all the materials used to build the ship, the maximum mass of the cargo that can be brought onto the ship, and also the maximum mass of the ship's population in relation to the ship's volume. If they do not, the ship could possibly sink, which can lead to injuries and fatalities.
Wow! How else is density important in our everyday lives?
Well, Kelsey, I know you are an advocate for saving our environment. Density is very important when it comes to oil spills. Most oils are less dense than water, causing them to float. This characteristic is crucial during oil spills as it determines the spread and surface coverage of the oil slick. Floating oil can spread rapidly across the water surface, affecting large areas and making containment challenging. However, the density difference allows for the use of floating barriers or booms to contain the oil and prevent it from spreading further.
Wow! I didn't know that density was so important when it came to oil spills.
Well, now you know. Let me give you another example. I love many different foods and beverages. Density in cooking is very important when it comes to cooking times. In boiling, foods with different densities cook at different rates. Less dense foods like leafy vegetables float and cook quickly, while denser foods like potatoes sink and take longer to cook. Understanding density can help chefs time the cooking process to ensure all ingredients are perfectly cooked. Also, when baking, the density of the dough determines the texture of the baked goods. A denser dough produces a heavier, more compact bread, while a less dense dough produces a lighter and fluffier bread. Density is not only important regarding cooking times and dough texture, it's also important when it comes to visual appeal for layered beverages and desserts. By carefully selecting ingredients with different densities, chefs can create distinct layers that do not mix. For example, in a layered beverage, Denser liquids like syrups are poured first, followed by less dense liquids, resulting in beautiful separated layers.
Interesting. I'll keep this in mind when I'm cooking at home.
Great! Check out this experiment investigating the order in which different liquids are layered according to their density. Students can try this experiment at home or at school under the supervision of their parent or teacher, following all safety precautions. For this experiment, you will need a measuring cylinder or a measuring cup if you don't have a measuring cylinder available, an empty glass, a quarter cup or 60 cubic centimeters of water, a quarter cup or 60 cubic centimeters of syrup, a quarter cup or 60 cubic centimeters of cooking oil, and 2 to 3 drops of food coloring. Before we pour the liquids in the glass, can you predict the order of the liquids, oil, water, and syrup from top to bottom in the glass? Okay, it's time to pour. First, pour the water into the empty glass. Then put 2 to 3 drops of coloring into the water to give the water some color. Then pour your syrup. Next, pour your oil. Allow the liquids to settle. Here we can see that the oil is the topmost layer, the water is the middle, and the syrup is on the bottom. Was your prediction of the order of the liquids correct?
Yes.
Great!
So, from our results, we can therefore infer that the oil is the least dense of all the liquids and the syrup is the densest. Water, however, is less dense than the syrup but denser than oil.
You are on point.
Thank you.
Now let's recap what we've learned by answering these questions. Question 1 says, define density. Do you have the answer, Kelsey?
I thought you'd never ask. The density of a substance is defined as its mass per unit volume.
Correct. Question 2 taken from the CSEC Specimen Paper 1, 2012, question 16 says 400 kilograms of methylated spirit occupies a volume of 0.50 meters cubed. What is its density? How would you solve this problem, Kelsey?
The question gives us the mass of the methylated spirit, 400 kilograms, and its volume, 0.50 meters cubed. The question asked us to find the density of the methylated spirit. I'll first state the formula for density. Then I'll substitute. Our answer is 800 kilograms per meter cubed, and when written in standard form is A, 8 by 10 squared kilograms per meter cubed.
Excellent! Our last question states, describe one example that shows the importance of density in our everyday lives.
Well, since I cook and bake at home, I'd say when baking, density is important when producing the dough for baked products. The density of the dough determines the texture of the baked goods. A denser bread dough results in a heavier, more compact bread, while a less dense dough produces a lighter and fluffier bread. If you'd ask me, I'd prefer a fluffier bread.
Very good answer.
Thanks. I sure learned a lot about density today. Who would have thought that a simple trip to the beach would have led me into the land of density?
We discover and learn new things every day.